Hello, I will talk about special relativity and the twin paradox. Special relativity is an explanation of how speed affects mass, time, and space. As an object approaches the speed of light, the mass of the object becomes infinite, and so does the energy required to move it. This means that it is impossible for any matter to go faster the speed of light or even reach the speed of light. Now I will talk about the twin paradox. The first twin flies into space at a very high speed, for example 240,000 kilometers per second, and returns to Earth while the second remains on Earth. According to the theory of special relativity, movement at high speed slows down the flow of time. So the brother who went on a journey in space will return to Earth 10 years younger than his brother who stayed on Earth. I will describe the paradox in detail. One twin remains on Earth while his brother moves away in a spaceship at a very high speed, close to the speed of light. At some point, the brother turns around and returns to Earth. According to the theory of relativity, the journey in the spaceship will take less time than on Earth, which lead to the brother in the spaceship returning younger than the brother on Earth. For example, suppose the journey is to the star Epsilon in Eridanus, which is about 10 light years away from the solar system. And the speed of the spacecraft is 80% of the speed of light, that is to say 240,000 kilometers per second. According to the twin left on Earth, the round trip time as measured on Earth is T naught equals to 2 times L naught divided by V. So the total way is actually back and forth from Earth to the star Epsilon and back to Earth. So it is 2 times the way from Earth to the star Epsilon, that is 10 light years. So it is 2 times 10 light years divided by the speed of the spacecraft, that is 80% of the speed of light, that is 240,000 kilometers per second. So the total time that passed on Earth during the journey of the twin brother in the spaceship until he comes back from the journey will be 25 years. And according to Lorentz transformation, the time measured by the twin in the spacecraft is T spacecraft equals to T naught times root of 1 minus v squared divided by c squared. So the total time that measured in the spacecraft will be the time that measured on Earth times root of 1 minus v squared divided by c squared, and actually is because of time dilation in the spaceship that is moving in a very high speed. Because of the fact that the twin brother that is in the spaceship travels at a very high speed, then the rate of time flow in the spaceship will be slower than the time flow on Earth. This phenomenon is called time dilation. So, because of time dilation in the spaceship, the flow of time in the spaceship will be slower than the flow of time on Earth. So the total journey will be only 15 years and not 25 years. If it will be shorter by 10 years. Because of time dilation, of time lengthening. The rate of time flow in the spaceship is slower than the time flow on Earth. That is according to special relativity. So the total time, as I've already said, will be only 15 years. Okay. According to the twin in the spacecraft, he is at rest, while the Earth on which his twin brother is and the star Epsilon in Eridanus are moving across it at a speed of 80% of the speed of light. As a result, the distance between them shrinks according to the Lorentz transformation. So the distance it must travel is L spacecraft equals to L naught times root of 1 minus v squared divided by c squared. So the total distance between Earth to the star Eridanus will be 10 light years times 1 minus v, root of 1 minus v squared divided by c squared. This phenomenon is called contraction of distance, because from the point of view of the brother that is in the spacecraft, he is not moving, and the star Eridanus moving towards him at a very high speed, and that is the reason that there will be distance contraction. So the distance between Earth and the star Eridanus will be contracted from 10 light years to 6 light years only, because of the fact that the star Eridanus or the star Epsilon moving towards him in a very high speed. So the length, the distance between Earth and the star Epsilon will be contracted by 30%, by 40%, from 10 light years to 6 light years. And that is according to special relativity. There will be a space contraction because the star Epsilon moving towards the spacecraft in a very high speed. That is in the point of view of the twin brother that is in the spacecraft. He is not moving, and the star Epsilon is moving towards him at a very high speed. That is the reason that there will be a space contraction. And the total distance between Earth and the star Epsilon will be only 6 light years. So, and the total distance that the twin brother that is in the spaceship will have to travel after the contraction of the distance between him and the star Eridanus. The total distance back and forth will be T spacecraft equals to 2 times L spacecraft divided by V. So it will be 2 times the distance between Earth and the star Epsilon after the contraction. So after the contraction, the distance between Earth or between the twin that is in the spacecraft to star Epsilon is only 6 light years. Yes, and so the total distance back and forth will be 12 light years, is the total weight divided by the speed of the spacecraft, that is 0.8 or 80% of the speed of light. So the total time is the total weight divided by the speed. The total time that it will take to the twin brother that is in the space to do all the journey will be only 15 years because of the contraction of distance. Okay? Therefore, the two twins effectively agree that the twin in the spaceship will be younger when they meet again, in terms of the twin that remains on Earth due to the effect of time lengthening. Yes, that thing I have already discussed about it. the time lengthening or the time dilation, and because of the fact that the brother that stays on Earth sees his twin brother moving in the spaceship in a very high speed. So because of this, there will be a time dilation, time lengthening. And in terms of his traveling twin, due to the contraction of distance. Yes, as I have already said, the distance between Earth and the star Epsilon will be contracted from 10 light years to 6 light years only. So the total distance back and forth will be 12 light years divided by the speed of the spacecraft, that is 80% of the speed of light, that is to say 240,000 kilometers per second. So the total way divided by the speed is of course the total time that it will take to the brother in the spaceship to do all the journey. So it is 12 light years divided by 80% of the speed of light, and the total time that it will take him will be only 15 years. Okay, thank you very much.